relationships, and interpolation and extrapolation. We're going to be starting to look at interpolation and extrapolation, but the first thing we have to be very good at is understanding what a line of best fit is. We have to look and be able to identify when it's a good line of best fit and when it's not. If we look at this line of best fit, the points aren't evenly spaced. And that is, they're not evenly spaced above and below the line. I've got 1 point above, and here I've got 1, 2, 3, 4, 5 points below. Same issue in graph number 4. If I look at graph number 1, I've got 2 points above and 3 below. And in graph number 3, there's 2 points below and 3 above. If I look here, I've passed through 1, 2, 3 points, and here I've passed through 1, 2, 3 points, and there's that third point just off to the side. Which one's really the best fit? They're both pretty close. We're not going to get a lot more accurate. To me, graph number 3 looks a little bit better because it's following a little more the pattern and the shape of the data, whereas this one still kind of has a couple points at the end here that are not really representative of the pattern. So we can now, with this one here, graph 3, we get a little bit better look at the pattern. It looks like the points are more tightly clustered to the line. So the points aren't as tight to the line in this one, graph number 1, as they are in graph number 3. Not as tightly clustered. So our line of best fit is what we use to make predictions for values that are not actually recorded or plotted. So if I look at this graph is representing interpolation. I can see I'm moving upwards to my line of best fit and across to read the value of the dependent variable. And I'm going in between two pieces of data. In this example here, I've had to extend my line of best fit in order to take a value of the independent variable, go up to the line of best fit, and then draw a horizontal line across to the dependent variable to determine its value. In addition, I could also do this the other way, know a value for my dependent variable, draw a horizontal line to my line of best fit, and then draw a vertical line down to my independent variable to determine its value. And of course, to do this properly, you would use a ruler to enable the most correct data you could get, or the most correct results, sorry. We're going to look at an example now, and it's talking about a science project where a student recorded the minimum temperature in her backyard for the first 10 days in March, and the data is shown in the table. So the independent variable, we have two variables, day and temperature. Obviously, the temperature isn't determined first, the day of the year is, so it's independent, and the dependent variable is the minimum temperature, because of course, we kind of have an idea when we know the date what the temperature is going to be like based on past history. So when I look to create a scatter plot of the data, the first thing I need to do is create my scale. So the first thing I need to do is figure out how many boxes I have to work with on my graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there's 19 boxes I'm going to use horizontally, and 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 boxes I'm going to use. I think I said horizontal and vertical the wrong way. I apologize. So there's 19 boxes along my horizontal axis, or x-axis, or independent axes, and 19 boxes along my vertical, or dependent, or y-axis. So that's the first step. The next step is to determine my horizontal scale. I always do my highest value, subtract my lowest value. So it's 10 take away 1 divided by 19, which is around 0.473. Now to get my vertical scale, again, I take my highest value, which is 3, and I subtract my lowest value, which is -9. So I have 3 take away -9 divided by 19. That's 12 divided by 19, which is about 0.6. Neither one of these are nice numbers, so I'm probably going to count by ones to make my life a little bit easier. Now, this is a little bit different because a lot of the graphs we've done so far, or a lot of the scatter plots, have all been first quadrant graphs. I've got a lot of negative y values in my data. The smallest negative y value I see is -9. So I'm going to maybe start at -12 just so I leave myself room if I want to interpolate or extrapolate. I don't want to number every box because that becomes very cluttered. So I might do every other box. And that's 0, so that's where I'm going to put my horizontal axes. And of course, you're going to use a ruler when you draw your axes, and don't forget the arrows on your axes. You will have a ruler. I do not. And I'm going to keep counting 2, 4, 6. And this was my temperature. It needs a label. And really, we should write the full word out, but I'm cheating for the sake of time. The horizontal axis is the day in March, or the date in March would probably be better. The other thing I haven't done yet was draw my vertical axes on. And again, you're going to use a ruler. I do not have one, so that works with the Smartboard software very well. So now we're going to go back and we're going to get our ordered pairs. The first one is 1 and -9, so that tells me to start at the origin. +1 means move right 1, -9 means count down 9. Next point is 2 and -6, so I'm starting at the origin. I go right 2 and down 6 because negative numbers for the y coordinate or dependent coordinate tell you to go below the x-axis. Positive numbers would tell you to go above. Similarly, negative x values would tell you to go before the y-axis, and positive tell you to go to the right of it. The next point, 3 and -3. I'm going right 3 and down 3, plotting my point. Next one, 4 and -5, right 4 and down 5. 5 and -4. Went the wrong direction, sorry. 1, 2, 3, 4, 5, and -4. And then 6 and -1. 1, 2, 3, 4, 5, 6, and -1. Wrong direction again. 7 and 0, and I'm counting 7 across. 1, 2, 3, 4, 5, 6, 7 across. And I stay right here on the axes because the dependent variable was 0, so I don't move off the axes. 8 is -1. So across 1, 2, 3, 4, 5, 6, 7, 8, and -1. I believe 9 was 2, and 10 was 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9 across, and up 2, and 10 was at 3. Now, there is one thing I have forgotten to do here, which is going to cost me marks on a test. I forgot to number my horizontal scale. And again, I'm not going to number everything. I'm just going to count, and every 5 boxes, I'm going to increase by 5. And the other thing I need is temperature. So what was this data? It was the minimum temperature in March. So I need a title. And again, you're going to do this a little bit more neatly because you're not doing it with the Mobi and trying to make the Smartboard software work. Okay, so trends in the graph. What's happening? As the days increase in March, the temperature is also increasing. So what type of relationship is this? Are the points tightly clustered together? Absolutely. They're increasing. So we could call this a strong positive correlation. Now the line of best fit for this graph. We're going to grab this green line and we're going to maneuver the line around, and we're going to try and pass through as many points as we can and try and have everything else kind of spread out above and below. We really have 1 point below. Right now I have 5 above, so that's not a great fit, is it? So maybe I need to maneuver a bit more that way. I've got 1, 2, 3, 4 below, 1, 2, 3, 4, 5 above. I'm really going through 1 point. It's kind of difficult to do sometimes, and you're not going to get it perfect, but we're looking for something that looks close where the points are tightly clustered around the line of best fit. Okay? And before you come to class tomorrow, please do page 14. 1 ABCD, and 2 ABCD.